Unit 7, Chapter 10.2, the multiplication property of equality. This is similar to the last unit, but instead of using addition-subtraction, we're going to use multiplication and division to eliminate numbers from the side of the variable. So let's look at the multiplication property of equality. So like the last section, we have a claim here that two expressions are equal to each other. For example, 2 times 3 is equal to 6 is a true equality. And it just says that if I multiply both sides by exactly the same number, then they will remain equal to each other. So for example, if I multiply both sides by 4, then 2 times 3 times 4 is 24, is still going to be equal to 6 times 4, which is 24. So to keep the equation balanced, you must do exactly the same thing to both sides. Okay, again, we're not concerned as much about these words as what they mean. Okay, and so here, the multiplicative inverse, if I have some number and I multiply it by its reciprocal, or 1 over itself, it always will equal a 1. For example, if I have 3 and I multiply it by 1 over 3, well, I can think of any whole number as a fraction, and we can see by cancellation or just multiplying straight across that we get 3 over 3, which simplifies to 1. Okay, and dividing by a is the same thing as multiplying by 1 over a. Okay, for example, 3 divided by 3 is equal to 1 is exactly the same thing as 3 times 1 over 3, as we have here, 1 over a, and as we just showed here to the left, that is also equal to 1. Then we have the multiplicative identity. Okay, that means that if we take a number and multiply it by a 1, what we get back is that original number. So multiplying by 1 has no effect. So let's look at how this property is used. So here we have the same objective. We want x by itself, and we have to take a look at the number 4 that needs to be eliminated. In this case, 4 is multiplying the x, and so we got to use the property of eliminating it by, in this case, multiplying by its reciprocal, or which is the same thing as dividing by that number. So if I take 4 and I divide it by 4, I can do that, but remember, I must also do the same thing to the opposite side of the equation. Well, 4 divided by 4 is 1. I'll write it this time, so I have 1 times x on the left, and 12 divided by 4 is 3. And as we just saw, multiplying any number by 1 has no effect, so 1 times x is just x. And so there would be the solution to my equation. Do I know it's correct? Well, if I go in and replace the x with its solution, I have 4 times 3 is equal to 12. That is true. So that is the solution. Here I have the 3 in the denominator. X is being divided by 3. And again, you don't have to do this, but you can think of this problem as really 1/3 times x is equal to 2. I broke it apart, and then how do I eliminate the 1/3? Well, I multiply by its reciprocal, which is 3. I'll write it as 3 overrun. But remember, if I multiply the left by 3, I must multiply the right by 3. Okay, and we know that multiplying any number by its reciprocal will equal 1. So once again, I have 1 times x, or 1x, and 2 times 3 is 6. There's no need to write the 1 because it has no effect, so it's really just x is equal to 6. How do I know it's correct? Well, if I replace the x with a 6, 6 over 3 does equal 2, and so the answer checks. It doesn't matter which side the variable is on, so in this case the x is on the right side, which means I need to eliminate the -3. To eliminate a -3 that's multiplying, I go ahead and just divide by that number. If I do it to one side, I must do it to the other. When I complete the division, a negative divided by a negative is a positive, so that works out to be a positive 5. Negative divided by a negative is equal to a positive. I'm always going to divide by exactly the same number to include its sign so that the answer will always be positive. In this case, I'll just write the x because it's really 1x, which is just x, and so here's my solution. How do I know it's correct? Well, let me plug it back in to the equation. Negative 3 times 5. Well, negative 3 times 5 is negative 15, so negative 15 does equal negative 15. The answer checks. And one last example. Here the x, or the variable, is being divided by 3, so the opposite operation would be to multiply it by 3. I'll write it as a fraction, although I don't really have to. And on this side I must do exactly the same thing. I know these 3's will cancel out to be 1's, and so what I end up with is 1 times x, which is just x, and on the right side, negative 8 times 3 is negative 24. Is it correct? Well, negative 24 divided by 3 is equal to a negative 8. Negative 8 does equal negative 8, so the answer checks. That concludes this section.